What up, algebra superstars? Oh, you thought I was going to say it again. There's 2 videos in a row. You thought I was going to say squad. You got it wrong. You don't know me. You don't know me. I am unpredictable. I am inevitable. All right, making sure my whiteboard is working. It's working. All right, so the title of this one is Division Properties of Exponents. We're still dealing with exponents, but now how do they behave with exponents, right? So if you look at these two ideas that I have here, one of them is with numbers, right? We have a base of 2, and the other one is a base of variables, r. So how do numbers behave with exponents? Can we add, subtract, multiply them, and divide them, even though we know or don't know the numbers? That's pretty much what we're trying to do here. That's what we did in the last video with the multiplication properties. Now we're dealing with division. So what does it look like? Well, if I have 2 to the 8th power, I can actually take 2 to the 8th power and before I make a mistake, let me actually put it in the calculator, 256. So if I grab 2 to the 8th power, if I put it in my calculator, just like I showed you guys in the last video, I get 256, right? And then so I put, once again, 2 in my calculator, then ask my calculator to change the exponent, and then change it to the number 3. So 2 times 2 times 2, that is going to give me 8. And then that is very simple math right here. 258 divided by 8, that is going to give me a total of 32.25. 32.25. So I need you to understand that this is not what we're doing. This right here, what I just showed you in red, is not what we're doing, because we should already know how to do this. This is something that once you're in algebra, you already know how to do this. We need to learn how to simplify when you have unknowns, right? So how do you deal with an r to the 5th power and r to the 4th power that's dividing, right? We can't get a solution that's like this one. Now, let me show you how we can get 32.25 in a slightly different way, right? By breaking everything down, and then we could do the same thing with r. So first step is understand what is it that we have. We have 8 2s at the top, right? Multiplying, and 3 2s at the bottom multiplying. That's what it means to be 2 to the 8th power and 2 to the 3rd power. Now, what you see here is subtraction. Anything divided by itself is 1, right? If you grab this 2 right here and divide it by this 2, it's going to equal 1. And when you're multiplying, right, because that's essentially what we're doing, does a 1 matter? No. That is why we can say that they cancel out. So this will create a 1. That will create a 1. A top 2 and a bottom 2 will create a 1. And all that we're left with is this right here, with just 1, 2, 3, 4, 5 2s at the top. Now, we can just wrap those up neatly and say 2 to the 5th power. If you grab your calculator and you put 2 to the 5th power, did I make a mistake here with my division? I think I did. What number did I say? 2 to the 8th power. It's 256. What number did I write? 258? I don't know. Okay, so 256 is 2 to the 8th power. Sorry. You see, that's why I bring up my handy dandy, and I still make mistakes. Jesus Christ. And this is still going to give me 8. So yes, this should divide 256 divided by 8. Now that I'm remembered, I think I did put 258. I think I messed up with that number, 258. But this right here, I'm sorry, the true 8th power of 2 is 256. Guys, you got to understand that I'm making this video so early. So this will give me 32. Right? So right off the bat, like I was saying before, this right here is not really what we're focused on. That's not what we want to do. Even though that is the solution, we want to understand how can we simplify it. Now, 2 to the 5th power, if you grab 2 and you take it to the 5th power, hopefully you guys do remember how it is that you bring it into your calculator. That will get you. That's the same thing as saying 32. Okay. So if we know how the numbers are behaving, right? If we could see that the steps here make sense, we can apply that to the r's as well. We can go ahead and expand them, right? We have 5 r's on the top. 1 on the top cancels 1 on the bottom. Cancel, 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 cancel. Sorry, 1, 2, 3, and then 4. So 4 on the top, 4 on the bottom. We're left with 1 r at the top. So our answer here is just r. Whatever r is, doesn't matter what number that is, it's going to be just that number. So can you see the pattern or the easy way to get to the answer? What do you notice what's happening when you cancel out? What is the operation that happens when you're canceling out? Even though we are dividing, right? Even though it says division, the actual property that's happening is from 8 and 3 to get 5, you just simply subtract. I hope that made sense. So if you look at this think about question, right? Think about it. What steps would you take to simplify the one that you have here? Well, you keep your base of 10 because we know we're going to have 12 tens at the top, right? We're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are all tens, right? And then you have 9 tens at the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So, and then now what we do, and I'm not going to write them out, and you delete 1, 1, 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8, that's 9. 9, 10, 11, 12. Okay, cool. You could see that that's going to leave me with 10 to the third power. Okay, so that is pretty much what we have. That's it. What we're doing is understanding how the numbers work when with exponents and utilizing those steps for variables when we don't know what the number is. Once again, here you have it. When your two numbers that you're dividing have the same base, right? They have to have the same base for this to work. If they don't have the same base, meaning they're not the same, then you can't really cross them out. Why? Because you can do 4 divided by 4 equals 1, right? And you can just kind of cancel that out because remember, 1 is not really important in multiplication, right? But when you have the numbers 2 over 4, that doesn't really cancel out into 1. That doesn't make 1. So it has to be the same exact thing. So if you have R on the top, it has to be R on the bottom so it can cancel out to make into a 1. And don't forget, a 1 is important in certain situations, but in multiplication, it is not. So just to say it again, what we're essentially doing is subtracting those exponents. And the order of subtraction does matter, okay? The order of subtraction does matter. So if you have x to the 5th power on the top and x to the, let's call this 7th power on the bottom, you do have to follow the order that you have. Notice that m is on top in the numerator and p is on the bottom. And the way that it's written is m goes first, so numerator, top number goes first, and p, denominator, goes after. So what this is you have to write it as 5 minus 7. Remember that subtraction order is important. Order is important. Order is important. Order is important. It is very important. This will give you this answer right here. The order in which you write it is important. So keep that in mind. All right, let's go ahead and do the first example so we can see how simple this is. We have b to the 5th power, c to the 7th power. They're multiplying. And we have it divided by b to the 2nd power times c. Now, for this first time, I'm going to expand everything out just so you understand where everything is coming from. Understand that you don't have to expand it all the time. 3, 4, 5. You're going to understand that, or you're going to see 1, 2, 3, 4, 5, 6, 7, that sometimes the amount of numbers that we have here can be very annoying and the amount of times that we need to write these things. So it's not going to make sense to just rewrite or expand something over and over and over again. As long as you could see this first time that I'm doing it right now and understand it, it makes sense. That's it. All right, so we have 1, 2, 3, 4, 5 B's on the top, 7 C's that are multiplying on the top, and then 2 B's multiplying on the bottom with 1 C that's multiplying on the bottom. The way that we simplify this is we want to say, okay, this can divide out with this one to make 1. It doesn't become 0. Please understand that it doesn't become 0. Because if you say that this becomes 0, then essentially, since we're multiplying here, you're canceling everything out. And that's not what we're doing. It becomes 1. And 1 is not going to make a difference in multiplication. This divides with this. And that's pretty much it. I canceled 2 B's from top and bottom. And then I'm able to cancel 1 C from the top and the bottom. So what am I left with? Well, what I'm left with is 3 of these. So 3 B's that are multiplying is b to the 3rd power. And then on the top, I have 1, 2, 3, 4, 5, 6. Yeah, 6. C to the 6th power. And I'm done. I have nothing on the bottom. There's no denominator. The bottom is gone. Also, please don't write 0. Don't write that because that does change a division. Remember that these numbers right here turned into 1s. So you can essentially say 1, right? And dividing by 1 doesn't matter. That's why I'm saying that these numbers just go away, okay? So the difference between a 1 and a 0 in these type of problems can make or break your answer. That's it. That's the final answer. Moving on. Go ahead and try. Simplify as much as you can. Go. Okay. Now, I'm going to do this one a little bit quicker. I'm going to do it a little bit quicker. What I'm going to do this time is I'm going to leave it the way it is. I am not going to expand it, and I'm just going to already start doing my elimination right away. If I look at my numerator, the top part, I can see that I have a to the second power. Nowhere else do I have an a. Nowhere else do I have a here in my problem. So my answer will have an a to the second power in the numerator. It will. It's not going to match with anything else. It's not going to add, subtract, multiply, divide, nothing. There's no a, no other a's to do this with. Now, for b's, please understand that I have 9 on the top and 8 on the bottom. When you subtract that, when you start canceling them out, how many b's will you have left? Do you understand it? Do you agree with me that all these 8 of them are going to get rid of 8 from here, leaving 1 b at the top? There you have it. It's as easy as that. The c that you have up here will cancel out with the one that you have down here. They divide out to make 1. And the 4 that you have here, 4d, and the 1d, well, this 1 will cancel out with one of the ones here, leaving you with 3. So d to the third power. Now we could see that we have nothing in the denominator. Don't say that we have 0. Don't say that we have 0. When we have nothing in the denominator, is the same thing as having a 1, which we don't really need, right? Anything divided by 1 is the same thing. So there you have it. The answer for this track problem is a to the second power times b times d to the third power. All right, next one. Boom. I know it's a word problem. I want to give you a few seconds. Please read it so you can understand it yourself, and then we'll do it together. All right. Example number 2. At sea level, there are about 10 to the 25th power molecules in a cubic liter of air. In the stratosphere, about 30 kilometers above the Earth's surface, the same cubic liter of air has about 10 to the 23rd molecules, power of 23. Approximately how many times as many molecules are there in a cubic liter of air at sea level as there are in the stratosphere? A lot of you guys are like shaking in your seats already, right? Well, this problem seems to be a lot simpler than you think. I want you to think about the easy idea of comparing numbers, right? How many times more is this number bigger than the other, right? How many times more, right? That's pretty much what we're saying. How many more times is one number than the other? Well, think about something simple. Let's look at the number 5 and 10. I think that's one of the easiest ones to think about. The numbers 5 and 10. The numbers 5 and 10, how much bigger is the number 10? How many times more is the number 10 compared to the number 5? Right? What would you have to multiply 5 by to get to the number 10? And that's the number 2. It's 2 times more. And how do we find that number? Instead of me wording it as how many times we'll have to multiply 5 to get to 10, the way that we compare numbers is by doing ratios. Ratios are fractions, right? So 10 divided by 5 gives me 2. This tells me that 10 is 2 times bigger than 5. All right? It works with any number. 15 and 3. How many times bigger is 15 than 3? It's 5 times bigger, because if I grab 3 and I multiply it by itself, I'm sorry, not by itself. If I add it to itself 5 times, it's going to give me 15, right? And if you flip it, you have the reverse idea. 5 divided by 10 does not give me 2, so be careful. 5 divided by 10, all I can do here is simplify, divide the top and the bottom by 5, and I get 1/2. So the way that I'm talking about it now, it's different. 10 is 2 times bigger than 5. That's what I'm saying here. 5 is half of 10. Ta-da! You see how it's different? The way when you flip your numbers, you now have a different, it's the same idea, but your sentence is different because you're saying it from the bigger number compared to the smaller number, or smaller number compared to the bigger number. So we're going to do the same thing with these two numbers. We're going to grab 10 to the 25th power, which is larger, right? How many times? And we want the bigger one because it says approximately how many times as many molecules are there in the at sea level And then we have here, at sea level, it's this one. So we do want to talk about the bigger one compared to the smaller one. So how many more times? So that's when I will grab this and tell me if not, that this looks exactly like we were talking about before. What's going to happen here is that we grab, you know, the shortcut of this is just pretty much put 10 to the 25th power in your calculator divided by 10 to the 23rd power in your calculator, and you got the answer. But that's not the idea of today's lesson. The idea of today's lesson is understanding what's happening here. And that's what's happening is we keep the same base. 25, right, minus 23 will give us 2. That's it. It's as simple as that. And this is something that you wouldn't have been able to do. Like, if there's anybody that's going to sit down and do this in your head and do this in your head, right? 10 times 10 times 10 times 10 times 10 times 10, sit there and do 10 times 10 times 10, 25 times and then 23 times. Heck no. And then divide it. Heck no. Those are 2 huge numbers. But look how simple this became. 10 times 10 is 100. That's my answer. I did not take out one single calculator. 10 times 10 to the second power is 10 times 10, which is 100. That's my answer. There's nothing else. It's 100 times bigger. So at sea level, we have 100 times more cubic liters. Let's look at our book here, just in case you guys have it around you and you want to fill in the blanks. So have it with you. There you have it. There are about 100 times as many molecules in a cubic liter sea level than there is in the stratosphere. Okay, so what seemed very daunting and scary at first, simple question. All right, go ahead and pause it right now. Do the same thing, same idea. Look at what you got and answer the question. All right. So we got Canada's West Edmonton Mall claims to have the largest parking lot in the world. Whoa, that's so cool, dude. With about 3 to the 9th power parking spaces. That's a large number. California's Glendale Galleria has about 3 to the 8th parking spaces. The West Edmonton Mall, I don't know why I feel like I want to say that in a funny accent, has blank times as many parking spaces as the Glendale Galleria. Now, before I get started, I actually want to tell you what that number is. I want to tell you that 3, if you haven't done already this math, 3 to the 9th power is 19,683. Well, that 6 was trash. 683. 683. So the one thing I want to tell you aside from this number is this is a good question to give to you in a non-calculator EOC day. So when you take your EOC at the end of the year, you will have for sure this type of question in non-calculator. And when you sit there and try to do this math right here, so 1, 2, 3, 4, 5, 6, 7, 8, 9. If you try to do this, I mean, by all means, if you have a lot of time left, do that. But I'm trying to save you because you're about to get to the 19,000s. If you understand that all you have to do here is, okay, we got 3 to the 9th power. That's the bigger number. So I'm going to grab the bigger number and compare it with my smaller number. And by the way, that 19,000 was only to get this number right here. Then you would have to get this number right here and then divide them, both of them. Heck to the no. I would not do that. So what's happening here is we have 3 9s at the top. Sorry, 9 3s. 9 3s at the top multiplying, and 8 3s on the bottom multiplying. So when we divide, the division property of exponents, we'll just simply say, just subtract them. Do the top exponent minus the bottom exponent to see what we have left. And what we have left is just 1 3. 3 to the power of 1, which is just itself, is just 3. So that is your answer. Nothing else, right? So you ask yourself if understanding these exponent rules are going to be better than doing all that math. Well, that's up to you to decide. All right, learn the power of a quotient. What is this? The power of a quotient is when we are taking something that is a quotient. Quotient is division. And remember that a fraction is division. Something that is a quotient and giving it an exponent, a power. So it's a power of a quotient. That's why it's called power of a quotient. Something that is dividing, you're giving it a power. How do we do this? The way that we do this is the way that I always preach whenever we have something outside of parentheses. You pretty much just distribute it. You distribute it. You give this 2 the power of 3, and you give the 5 the power of 3. So what's essentially happening is it's saying 2 times 2 times 2. There are 3 2s that are multiplying, and there are 3 5s that are multiplying. That's it. So it looks like this. The way that I do my work, I would be skipping this first step. I would just write it like this right off the bat. Or actually, I would write it where I would write it like this off the bat. I'd give the 2 the third power, and then I give the 5 the third power. That's what I would do right off the bat. As simple as that. But I'm just showing you. So there it is. Yeah. The way that I would do it, it'd go from here to here. That's it. And we know that we can answer this, right? We know that we can answer this. We can tell the calculator, or just that's going to be 8. 8 divided by 5 to the power of 3. 5 times 5 is 25. Times 5 more is 125, is it? To the third power? 125? Yeah. So it'll be 8 divided by 125. We're not trying to do this. I'm telling you right now, this is not algebra. This is not what the book is trying to teach you. Okay? What the book is trying to teach you is, well, can you do this? What would this look like? What would it look like? Understand that. Well, the way that that looks like is, I know that is 2 p's on the top multiplying and 2 q's at the bottom multiplying, and I can write it as p to the second power, q to the second power. Essentially, just give that to both of the to both items inside. Okay, now please understand that you are distributing that power to every little thing that's inside of the parentheses. Every little thing that's inside of the parentheses. This right here is straight from the book. Just to give you a little reminder, it's called the power of a quotient. All you do is you're going to go ahead and apply that exponent that's outside of the parentheses to everything that's inside of the parentheses. So they each get their own little exponent. Cool? They live happily ever after. And then simplify if you can simplify. For example, example number 3. Look at this one. What do we got? Well, we have inside there's division, which is, it's called quotient. The answer to division is quotient. And then outside we have a power. So this is a power to a quotient of a quotient, whatever you want to call that. But the most important part of answering this is distributing the 3 to everything that's inside. I am telling you that my most smartest students will get this idea. They get the concept, but they forget to distribute the 3 to everything. The 5 gets a power of 3. The 8 to the second power gets a power of 3. And the 6 gets a power of 3. What does that look like? Very simple. 5 has already a power of 1 because we don't see a power, so we assume that it's a 1. So we're just going to put a 3 right there. I'll go ahead and separate them by a little multiplication dot so we can give a little breathing space, right? A already has a power of 2, but what we're doing is we're applying another power. Do you guys remember what we do when we have a power raised to another power? A power raised to another power, or an exponent raised to another exponent, is the power to a power rule, which they multiply. That's what the 3 and the 2 do, okay? They multiply. Now, if you're having brain farts, if you're forgetting how, if that's true, or do I add them or do I multiply them? Do I add them or do I multiply them? Don't ever forget that you can always dumb it down to yourself. What 8 to the second power means is just 2 A's multiplying together. That's what it means. But if they want you to do that 3 times, that means that this is what it's going to look like. Right? So you did it once, twice, 3 times what's inside of the parentheses, right? And indeed, you're sticking with everything essentially is multiplying. So you can grab all of these, which is 6 of them, and just say that you have 8 to the 6th power. 8 to the 6th power. That's going to remind you that what you do with the exponents is multiply them in that instance. All right, we're going to go ahead and continue and finish this off with 6 to the 3rd power. What's next? Well, what's next is simplify as much as we can by doing everything we know how to do. Do we know what 5 to the 3rd power is? 5 times 5 is 25 times 5 more. That will give me 125. So I can simplify that. The 6 to the 3rd power is going to be 6 times 6 is 36 times 6 more. Okay, I have here 216. Okay. And then the A 2 times 3 is 6. Ta-da! Cool. Now, the next and last thing I'm going to do to make sure that this is my final answer is I'm just going to go ahead and say or ask myself, can I reduce the fraction 125 over 216? Can I reduce those numbers? And the answer is no. There is no number that I can divide both of these by, that number and that number, to make it a little bit prettier. What am I trying to say here? Well, what I'm trying to say is imagine that you had, let's still stay with 5 and 10. 5 and 10 is always so pretty. Let's say we had this as our answer. Well, we can actually simplify one step further. We can actually just deal with our numbers. We can divide the 5 by 2 and the 10 by 2 to get a, sorry, not by 2. We can divide the top and the bottom by 5. The 5 becomes a 1. And then the 10 becomes a 2. We can do that. That is doable. So I always like to check if my numbers are simplifiable, if there's a number that I can divide the top and the bottom by. Now, the only way or the only time that I can do this is when the only operation that's happening on the top is multiplication, and the only operation that's happening on the bottom is multiplication as well. If there is addition happening or subtraction happening, you cannot do that, okay? You cannot do that. But don't worry, we'll do it enough and we'll practice it enough so you can get reminded. Go ahead and get this check problem. Pause this right now. Try it on your own. All right. Here we go. Let's see if you did it the right way. The 5 gets a power of 4. The J that already has a power of 3 gets a power of 4. I'm guessing that's an L, which already had a power of 2, gets a power of 4. The 7 and the K also get a power of 2. You get a power of 4. You get a power of 4. Did I say power of 2? I meant power of 4. So let's go ahead and get started. I'm going to write it out the way that it was already. And then I'll add my red one. We'll call this L. So I'll write everything that I already have with a little bit of space so I can apply that new exponent. So 5 will get an exponent of 4. The J to the third power will also get it's a power to a power, so we multiply. Don't forget, I spent a little bit of time in the example problem before to give you that reminder. I'll tell you guys once again, and I'll tell you guys once again, and I'll tell you guys once again, one of the biggest mistakes is that the students forget to apply exponents to the numbers. Students forget to apply the exponents to the numbers. Don't forget, whatever's inside gets an exponent. All right, now what do we get here? 5 to the 4th power. So now 5 to the 4th power, which will be 625. I got 625. J, 3 times 4 is 12. So it's J to the 12th power. And 2 times 4 for L. 2 times 4 is 8. My J and my L look very similar. All right, there we go. And I don't know where my fraction line went so far out. What do we got here? 7 to the 4th power. So 7 to the 4th power. What do I get on that? I get 2,401. 2,401. Ooh, I might be able to reduce these numbers. Let me see. And then we have K. 5 times 4 is 20. Now, notice that there are no variables on the top and the bottom that are the same. I have a J and an L on the top and I have a K on the bottom, which means I'm pretty much done with reducing my variables. There's nothing else that I can do with reducing those variables. Now, 625, I'm putting it in my calculator as a fraction over 2401. And let me see if it gives me a reduced amount. No, it doesn't give me anything nice. So that is what I'm going to keep as my final answer. All right. How do we feel? How do we feel? How do we feel? Where are we going? Tap, tap, tap. Example 4. All right, example 4, power of a quotient with variables. Same idea, but now this one has a little surprise within it. It's nothing crazy, nothing new. You actually already know what you're supposed to know this already, but we haven't practiced it, so it probably sneaks. It's sneaky since we haven't practiced it. So how do we solve this? Well, You got two options here. You really do have two options. You have two avenues. You can start by distributing the two. You can. But the true way, when you do PEMDAS is to solve what you can inside of parentheses. So what I'm actually going to do is I'm going to do it in two different ways. What I'll start by doing is I'll distribute the two first. I'll go ahead and distribute the two to everything. Let me actually copy and paste this so I don't have to rewrite it. So give me a second. And I highly encourage you to copy and paste it as well. I'm going to clone it. And let me actually do it on the bottom. Okay. You get a power of 2, you get a power of 2, you get a power of 2, you get a power of 2. Everybody gets a power of 2. All right, what does it look like? X to the 4th power, then raised to the power of 2. Y, so I'm going to separate them by multiplication. I'm just going to, I don't know. You don't have to put that dot there. There's no police that's going to make sure that you put that little multiplication dot there. Actually, it's now annoying me that it's there for whatever reason. The x that didn't really have an exponent, it really does. It has an exponent of 1, but now it has exponent of 2, y to the exponent of 2, z to the exponent or to the power of 2. Now, I'm going to take this one step further and write it as x to the 2 times 4 is 8, y to the 2nd. So all I did is multiply the 4 times 2. That's literally all I did. X, y, z, and they all have 2, 2, 2. Now, you might think that we're done, but the truth of the matter is we're not. And I kind of mentioned it in the last problem. We now have, after the distribution, we now have a little bit more to cancel out. If you ask yourself, do I still have the same letters on the top and on the bottom? If you do, that's a huge warning that you're not done. If you have the same letters on the top and on the bottom, so you have x's on the top, x on the bottom, y's on the top, y's on the bottom, you can still cancel them out through the quotient property, right? Remember that the 8x's on the top are going to, if you were to expand this out, right? The 8x's on the top, 2 of them are going to cancel with the ones on the bottom. So these 2 x's that are down here are going to go away with 2 of the ones from here. That's leaving you now with how many x's on the top? Multiplying 6. You will now have 6 x's on the top. If you are struggling in understanding this, you can always write them out. You can always expand it out. By all means, go like this. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2. Those are your y's, right? Okay, make sure you make a very clear distinction between x's and y's. And here you had 2 x's with 2 y's and 2 z's. And then what you're doing is canceling 1 and 1, canceling 1 and 1. So now look what you have. You have 6 x's left. Oh, sorry. 1, 2, 3, 1, 2, 3. 6 x's left. On the top and on the bottom, you're canceling, you're getting rid of your y's. There's 2 here, 2 here. So that's no more y's. Don't put 0, please, for the love of God. Do not put 0. Because remember that we're still acting in multiplication. And when you multiply by 0, everything goes away, especially in this multiplication and division problem. Do not put 0. Don't put anything. Just don't put anything. And then what we have is we still have 2 z's here in the denominator. They don't do anything. They don't cancel with anybody. So they actually just stayed as they originally were. That right there is your final, most simplified answer. Okay. So notice that this was distributing first. We distributed first and then we simplified. What happens if we take the other route first? Meaning I'm going to focus first in simplifying. I know that I have, looking at this, I have 4 x's on the top and 1 on the bottom. If I simplify it, that means that the 4 x's on the top will cancel with 1 in the bottom, leaving me with 3 x's on the top. Then, okay, so this one's gone. I'm so dumb. I just made a bigger x. That's gone with one of these. My y and y cancel out, leaving me with 1 z. So this is essentially what I have. Don't forget that we still have not applied our power. Look at what's going to happen. Once you do a power to a power rule right here, and once you distribute that, you're going to have 3 times 2 for the exponent of x. That's going to give you 6. And then z that had an exponent of 1. 1 times 2 is 2. So you choose that route. Whatever makes your mind a little bit more at ease. Obviously, the bottom one, you could tell that it's got a little bit less work. I guess because I unnecessarily wrote this step here by just doing 4 times 2, right? But there you have it. Nothing crazy. Let's go to our check problem. Pause it right now and try it on your own. All right. Let's see what we got. Okay. Now we're just checking our problem. I'm going to speed it up a little bit. So by speeding it up, that means I'm going to be skipping a few little steps. I'm going to apply a power to everything that I see inside, every single variable, every single number. So P, M, and 3, everything at all gets a power of 4. So 4 gets a power of 4. M that already had a power of 2 now gets multiplied by 4. So that power becomes 8. N also becomes 8. P becomes 8. And this, before I continue, as a reminder that you could have, yes, you could have simplified it before. And if you did, kudos to you, because I don't know, for taking a different route. M to the 4th power, P to the 4th power. What do I have? Do I have same letters on the top and on the bottom? I do, so I'm not done. I got these 4 will go away with 4 from here. Now, let me first take care of my 4 to the 4th power. That's going to give me 256. So I get 256 on the top. 3 to the 4th power gives me 81. All right, so I got that. Now, once again, the M's, I have 4 left over on the top. E, I have 4 of them here, cancel out with 4 of them here, giving me P to the 4th on the top. And I'm about to tell you something right now. The ends, there's no ends on the bottom, so they stay there. Now, really quick, if you guys see an answer in the book or in anywhere else that you're like, oh, but I wrote them in different order, just understand that the way to fully simplify this is from left to right. You always write the number first, so the numerical parts first, and then the letters go in alphabetical order. So my brain was cringy right now since I wrote the P in front of N. So well, that's whatever. It's not that crazy of a deal. So the next question I'm going to ask myself is 256 over 81. Does that simplify? And it doesn't. There's no other pretty number that's going to divide both of these and give me a sweeter response. So there you guys have it. Go ahead and take the time to do questions in page 17, questions 1 through 18. All right. If you need help, let me know. If not, peace out.